how stibnite forms. I'm really excited about this one because stibnite is actually one of my favourite minerals. As far as minerals go, I think it's altogether one of the coolest looking materials out there. So, in 5 easy beginner friendly steps, I give you how stibnite forms. Ingredients: hydrothermal fluids, transport of elements, precipitation, and crystallization. Stage 1: Ingredients. Now, the genesis of stibnite is going to begin with the presence of its primary ingredients, which consist of antimony and sulfur. Now, these elements generally tend to hang around in areas where there is usually quite significant and very noteworthy geological activity, and this is usually characterized by either volcanic activity or hydrothermal vents. Stage 2: Hydrothermal fluids. Hot water that is particularly rich in minerals, and we call these hydrothermal fluids, begin to move through cracks and fissures in the Earth's crust. Now, these fluids are heated by magma, which is essentially internal lava, and this can dissolve antimony and sulfur from surrounding rocks. Stage 3: Transport of minerals. The hydrothermal fluids that are now carrying this dissolved antimony and sulfur begin to travel through the Earth's crust, and as they move, they cool down. This is a natural process, and this changes the pressure, which affects the solubility of the minerals in that hydrothermal fluid. Stage 4: Precipitation. When hydrothermal fluids reach cooler areas, they encounter changes in pressure or chemical environments, and the dissolved antimony and sulfur are going to begin to precipitate or solidify out of that underlying solution. Now, this process results in the formation of stibnite crystals, often inside veins or clusters within the host rocks themselves. Final stage: crystallization. Over time, as progressively more and more hydrothermal fluids flow through those cracks and fissures, antimony and sulfur precipitate. Stibnite crystals, as a result of this precipitation, are going to continue to grow larger and more well-defined crystals. And the crystals can form in various different shapes, but they often form into the kind that they're known for, which is the long, slender, needle-like structures. So stibnite forms through the precipitation of hydrothermal fluids that are very rich in antimony and sulfur. Now, these precipitate and crystallize in cooler regions of the Earth's crust, and this process is generally driven by volcanic activity and hydrothermal veins. Let me know in the comments the kind of crystals, minerals, and precious metals you'd like me to cover next.